Hello students, in this video we'll discuss about how a symbol table is implemented and maintained, right? See, in the last video we have discussed what are the operations we can perform on it. So the last topic we have discussed about hash table, right? But there are ways to implement this symbol table. Like it's a data structure, so where we can allocate the memory in any way. Like the basic implementation techniques are list. So we can simply allocate the memory as a list like array, okay, or ordered list or unordered list, like you can say that uh, continuous memory locations or uncontiguous memory location, that's your wish, but the elements are going to be stored in a sequential order. The next one, self organized list. So in the list the fields are not having any relation, but in self-organized list we should mention the relationship between the phases, sorry, the records or entries, we can say that. So next one, binary search tree. So you know about that binary search tree property. So how the tokens are going to be stored as binary search tree, we'll discuss with examples. And hash table. So the main concept of hash table is key and hash function, okay, hash function. So means, for example, if you want are having 5 entries here, assume that 5 entries. So the index starts from 0 1 2 3 4. So in the hash table, for example, if I want to store a, and what is the ASCII value of a, assume that the value, okay, forget about the exact ASCII value, assume that we have given some value to the a as 15. Then what is the hash function we are using? Module, assume that, okay, module. Then our key is a. So a module, the size of hash table, what is the size of it? 5. So means what is the value of a here? 15. 15 mod 5, so the remainder is 0. Then we have to store a in 0, right? For example, if you are having b, which is also having the ASCII value of 25, then where we should store this? See, 25 mod 5, again it would be 0, right? Then again we have to store in the 0. So there are so many other ways to handle these conflicts, but you can insert one more and we can store the b here, right? Because it is having the same entry. Then assume that we are having c, which is 26, the value. So 26 mod 5, it is nothing but 1. Then we are going to store here c. And assume that we are having d, which is having 24. So what is 24 mod 5? It would be 4. Then we have to store in the fourth record d. So assume that we are having 19, like f equivalent to 19, or you take the 19 mod 5, again it is 4. Then we have to create one more for the f. And assume that we have x was is 35 or 30, whatever it is. So what is 30 mod 5? It would be 0, and but 0 is already having 2. Then you can insert one more, which is of c. Like that, there is no need to worry about that the memory is going to be fed. Of course, we'll discuss again with the example, because you know what is list and self-organized binary search tree. And of course you might be knowing this hash table also, but just tell you what exactly the hash function, I explained with a different general example. So later we'll go with the code. So first we'll go with the lists. See, the simplest and easiest way to implement the data structure for a symbol table is a linear list of records. Okay, we use a single array of collections, several arrays for this purpose to store the name and their associated information, and we'll use the operations like insert and lookup. We have already discussed in the operations of symbol table are begin scope and end scope are some minor operations. So there are two types of list. One is ordered list and unordered list. So this is the general structure of the symbol table. So what are the variable information and the space or the size required to execute it? And they are not limited, guys. You can add any number of right fields to it. And already we have inserted 4 records, and this is the empty space. If and the later in the program, if you have some other variables, you can insert there, right? So let me explain this list with a program, how they are going to be stored. See, always the execution, even though you have written something here, always the execution starts from the main. Okay. Then what is the first variable you are having here? U. So whenever an identifier is detected, a record will be inserted. That is U. And what is the information here? Integer. And what is the space? 2 bytes. Then we are calling sum function. Then automatically it will go to the sum function. And what we have used here, see, the global variables we have used. We are calling, whenever you are calling the sum, then first you have to go with the global declaration of the variable that we have stored A, B, C. When we are coming out of the main, so you must take care about the global variables. Without that declaration, if you start using it, you will get an error. So I've declared A, B, C with some information. So when you are coming to the sum function, again we have two variables x and y. Simply insert it. Okay, simply insert the variables and the function is sum. Like, okay, so whatever the identifiers we have used in our program, even main is also an identifier, right? So that you have to give in. So main integer, and what is the size of that? Okay, by default it would be taken as 2 bytes, then like that. So how many variables you have used in your function? So for every identifier you have to create an insert, and that too linearly. Whenever it is detected, you have to insert it. Okay, if the variable is already inserted, first you have to call the lookup. If it is already existed, update the other information whatever it is, otherwise just keep on going inserting if it is not existed. Then what is the main disadvantage of this list means, see, in some we are having the x and y, but there is no information related to that, which are related to what. And these abcs are related to all the functions, but there is no such information. And the u is related to main, so there is no such information about the relationship. So that we can specify in the self organized list. See, here we are reducing the time for searching, like by adding some field called linker to the each record, how it is going to be related. See, here in the normal list we are having just the information about the identifiers, but here we are specifying that like id1 is related to id2, id3 is related to id1. So like that we are giving some information about the relationship between the identifiers. That's it. So no other uh, difference between the list and self-organized list. And then another way is binary search tree. See, the binary search tree, you know about it. Binary search tree means a node is going to have only at most two children. So one left side node and right side node, and the left side node should be less than the right parent, and the right side node should be greater than the parent node. Then how we have to iterate, right? So again, the starts from main. First one is u, so that's why I created the u. Then we are calling the sum. Before, when you are going to the other function, first go with the a. See, a is less than u, you have to make it as a left child. B is less than u, greater than a, you have to create it. C is less than u, greater than a, greater than b, you have to create here. That same way, then we are calling some function x. X is greater than u, then you have to take it. And y is greater than u, greater than x, you have to create a node here. Then sum is greater than u, greater than x, right, y, then you can take it. Means, see guys, so the length, don't take only one variable, we are having more than one. That's the reason we have taken here. Okay, so this is about binary search tree. In the same way, the last implementation method is hash tables. So how this hash table, so I told you that it is a key and the operation. In open hashing we have to take it. So for example, 0 1 2 3 4 5 6 7 8 9 10 11 12, at 11, sorry. So what is the hash value for this 12? So in earlier video I told you now 12 hash value. So because the size of the hash table is 12, sorry, size of the hash table is 12. So then see, the hash table is an array index starts from 0 to table size -1. If it is 12, it should start from 0 to 11. And most commonly used data structure for implement the symbol table. This is the most widely used and common and widely used. See, in insertion and lookup operations can be made very fast with the order of one time complexity. For example, I want to check whether B is existed or not. Then whatever the hash function we have used to insert it, then directly it will direct you to the fourth. So for example, the hash value of A is 1, assume that. Then we have used the modular hash function. then 1 mod 12, so it is 1. Just go to the 1, you don't need to search linearly. So assume that the f hash function of f value is 11. Then what is 11 mod 12? It is remainder is 11. Then directly go to the 11th one and you check it. So you don't need to linearly check each and every field in the hash table, as we are having the time complexity of order of 1, right? So then every hash function maps an identifier name into a table index like A, B, C, D. Then we can go for it. So the name should be computed very fast, and all table indices should be mapped with equal probability. Like, don't think that 2 is having higher probability, 7 is having lower probability. No, everything is having equal probability. If you are having the same names with the same hash value, then we have to create a cluster like this. If B is having the same hash value and C is having the same hash value, you have to create a cluster, so that you don't need to worry about that the list is filled or the entries are filled. You can create any number of entries. So let me go with this, guys. Here A, B, C. So first you start with the main and U. Assume that the hash value will be created here U. Let me go with this. So then see here, we are going to store the entries into the symbol table based on the scope information. Now U is a different scope that I've created here by performing some hash function. Then let me go with the A, B, C. They are at the same level. Okay, so they are at the same level in as part of our scope. Then you have to create A followed by B followed by C, because they are at same level. Then sum is at different level, then we are creating it. But again x and y, they are at the same level. That's the reason in same record I've created x followed by y. So this is how we are going to insert the records into the hash table. So that is the end of symbol table. So in the next video we'll discuss about intermediate code generation, that is fourth unit.